here I would have 5.26. Again, if you're asking me what happened to all those zeros, remember, they'd be in front right now. They're in front of anything before this number. They don't mean anything. I can write 0, 5, or 5. It's the same thing. So that's where those went. You don't need to write those either. Example 4, 0.092347. 0.092347. What number does the decimal go after?
9.
Goes after the 9. Good. 9.2347. Okay. Remember then, it's always times 10. So that's the next step. I'm going to go through and put times 10 and everything. That's the easy step. Voila. All right. Then the last step is the exponent. Remember, the exponent starts off based on how many times we had to move the decimal. So in this problem, example 1, from here to there, which is where it ended up, that's one jump, and it went to the left. As you can see by rule, if we go to the left, it's a positive number. So it's just 1. There's your final answer. All right, look at the next one. 7,300,000. Started here, went to here. How many jumps would that mean I would have had to make? Shelby?
6.
6 jumps, good. In which direction?
The left.
I move to the left. According to the rule, left is positive. Okay. Example 3. 0.0000526. How many times did I have to move the decimal from here to after the 5?
6.
That's 6 jumps, and which way did I jump, right or left?
Right.
Okay, I moved to the right, so this is a negative. So -6. Last one, 0.092347. Remember, starts here, went here. How many times did I move it? 2 times. 2 times to the right, and according to the rule, that's a negative. Yes?
Is that always going to be the rule, right, negative, left?
For scientific notation, actually I should say standard form to scientific notation, yes. It'll be the backwards rule when we go the opposite direction in the next part. Okay, so that said, now let's practice going the other way. You're going to basically reverse everything we just did. All the rules go the opposite way now. Okay, you're going to take a number that's written in scientific notation and expect to turn it back into a number. Okay, again, everything is just backwards now. So, as you can see, I've got 7.2 times 10 to the 4th in the example I've done for you. The exponent still indicates how we move the decimal. If the exponent is positive, we're going to go to the right. If the exponent is negative, we're going to go to the left. So in 7.2 times 10 to the 4th, since 4 is positive, okay, that means we're going to take the decimal and go to the right. And the exponent's a 4, so that's 4 times to the right. So you can see I took 7.2 and I illustrated 4 jumps to the right. Now, as you can see, in 3 of those jump spots, there's a big old blank. When that happens, you put zeros in that act as placeholders. So in each one of those empty spots, I would put zeros in, and you'd end up with 72,000. Okay, so let's practice that. 5.1 times 10 to the negative 4. 5.1 times 10 to the negative 4. Right. So, if it's negative, which it is, that means we're taking the decimal and going to the left. So I'm going to have to take this and go 4 times to the left. That's why it's negative 4. So I've got 1, 2, 3, 4. Now, as you can see, I have 3 empty hoops. Same rule. You just put zeros there. So it's 0.00051. Ta-da. All right. 6 times 10 to the 11. So according to the rule, since it's a positive number, positive, which way do I move the decimal? Move it to the right. It's got to come to the right 11 times. So right now it would be after the 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As you can see, all of those were empty hoops. Okay, so I've got a 6 followed by 11 zeros. And if you're just randomly putting commas, don't. I'd rather you not put commas than put them in just randomly to make it look like a number. Okay? Some of you do that, have a tendency to do that with scientific notation. If you can't handle the comma part, leave them out. I'd rather a number look a little odd than look completely off because you don't know how to use a comma. All right, 1.02.